Yes, here. Got the code here. So this is the complex optimized code for symbol comparison, okay? Here. And here you have the mem move with the slow version. Anyway, it's complex. And here I've got integer division. It's quite simple. So when the Newton tries to call the integer division function, it just ends up here in native codes. I just get the register 0, register 1, perform the division directly, okay? Then I perform the remainder because the integer division also gets the remainder, and then set the results. And this is applied. This is applied here. Here you've got the patch codes, these only four. These 4 longs are just a kind of glue code that invokes some special coprocessor that only exists on the Einstein emulator. And it has another code which is the number of the patch. And here get at which address to do it. And actually the sign division, I just do it at the address of this function plus 8 because I skip the first 2 instructions that tests if the divisor is 0. Because if the divisor is 0, it throws some exceptions on complex code. So I don't recompile this and so on. And this is patched here. So here I apply the patches for ROM 717006, which is the US version, but I could do the same for German or image on here. So this is the Einstein code. It's nice. No, it's not? I mean, I like it.
So you're optimistic that there's plenty of room for optimization?
Well, this is one of the things that could be optimized. So more calls, profiling more precisely with like trying to decode the stack and with a specific time trying to figure out where the system is. And another thing is, for the moment, I do not compile a lot of stuff. And let me show you how I got. There is the big part of the code is here. Here, this is some madness here, which use C++ template metaprogramming, okay? So each instruction is compiled in the system into 16 different instructions for the 16 registers, for lots of things like this. For some instructions, there's just 26 versions of them, like here. So it uses template metaprogramming. This is why the code is so big and it takes something like half an hour to compile. And the problem with this is, so this is the generic version. The problem is here. Okay, so the main loop of Einstein is here. Okay, so unlike QEMU, QEMU uses the same thing as template metaprogramming, but with ugly C macros. So my code uses template metaprogramming, which is cleaner. But the problem is here, you've got the loop here. I just increase the PC program counter and then execute the function. Okay. And well, there's a lot of optimization with this. But the main problem here is that I cannot have the registers of the Newton to be mapped to registers of the host system. So what I want to do is, instead of calling a function, having called this in line with a switch with different things and just get out of the emulated mode and get in. The idea is to keep it portable as long as possible so we can adapt to x86 tablet PCs and with ARM CPUs. And the other problem is this. In this loop, I just have to test the signal, which is a kind of pointer here, to know whenever an interruption occurs, which is what a lot of emulators don't do. Like QEMU, for example, QEMU does not check for interruptions. And I need this because Newton operating system is a multi-threaded operating system with not a BIOS that I know, and I need to somehow have everything work at the same time. For example, when you draw on the screen, you need to stop immediately and record what you're drawing. Do you agree, Walter?
Well, there's a lot of ways to do that. That's true.
So you need to stop and to process the signal and things like this. all the time. So I cannot really ignore this. So, and when it's interrupted, it goes louder, blah, blah, blah. Okay, so it's quite big. And so this is one of the ideas. Another idea is to replace the microkernel of the Newton operating system could be entirely replaced with the virtual calls part I told you about. And once replaced, we could be free to get rid of a lot of parts of the operating systems. Just, I'll say this, the operating system spends a huge time trying to figure out which task to run and so on. And these bits could be replaced by native threads, for example.
So you will not modify anything. You will just.
It's modifying. It's modifying. This is the new thing.
Is it legal?
Yes, because it's modified this way. Modifying here. The first time you run the system, it just produces this file.
Okay.
I'm not distributing anything.
Okay.
I'm just checking this file that you provide from Newton. I create this one and I work on this one.
So you're responsible when you started out the first time?
Sorry?
As the user?
Yeah, but responsible for what?
Well, if somebody wanted to make a legal issue about modifying the ROM.
It's not modified.
Well, copying the ROM is the
Yeah,
problem.
it's copy from here to there. Hey, come on.
Well, you're copying it from the new to here.
But that's the user's responsibility, obtaining that first file.
Yeah, and you know there's a special format for ROMs. There's a special format which is debugger ROMs, and Einstein works with them, as well as dumps images. So you could use any ROM, including such ROMs that are already on the internet, or it's not my problem, it's yours. Yeah, there. Because actually this is an optimization because I use the Linux or the Mac virtual memory system here. And I just say the first 16 megabytes of the Newton system is this file. So I need to join this and this anyway. So this is 8 megabytes and this is go just afterwards. And I say this is read-only.
So, sorry.
Yeah, what parts of the Newton operating system would you like to skip? Is it the internet stack? PIP?
Oh, yes.
Yeah.
You could say this. So there is this is the source codes here of the Rex, okay? So a complex build system that's used classic. And in there you got some Newton script codes. And in there you got NIE bindings directly. So I started this. So basically, without installing NIE, the Newton software will believe that NIE is there. They already do with Einstein, but it doesn't work. And they're going to be able to directly connect to the internet using this interface. So we skip not only NIE, which is buggy, not only the communication layers of the operating system, which is probably the worst part, even if it has very nice design properties, and we skip the driver, the internet driver, and so on. And we directly have internet this way. Yeah, directly.
How does that, sorry, I missed the part of existing apps, how do they run through?
Well, it's going to look like NIE to the existing apps.
But when they call NIE calls, it's going to refer out to those contacts.
So I just do this actually. Here, where's the file? Is here. I just define the methods, the NIE methods. So for the moment, it just says there is only one link which is connected, and all this says, sorry, I don't work. And there's a link ID 0, and here just didn't finish to get the IP address. I say, sorry, I don't work. But it says, yes, I have some internet, which is class Einstein NIE. The setup is called Einstein. And it is always connected, and stuff like this.